Today, we're exploring a 2,000-year-old steam engine known as the Aeolipile. First invented by Hero of Alexandria in the 1st century CE, it would be another 1,500 years before steam power advanced any further. In this video, we'll look at different designs of the engine, how it works, and why it was never used practically in the ancient world. The Aeolipile works by heating water, converting it into steam, and directing that steam through radial tubes to create torque. In the conventional design, water is boiled in a reservoir beneath the turbine. As it turns to steam, it travels up through 2 pipes into the turbine, then exits through the radial tubes to make it spin. The main drawback is that steam escapes at the joints where the pipes connect to the rotating turbine, reducing efficiency. One way to solve this problem is by turning the turbine on its side and using it as the reservoir itself. In this setup, the water is boiled directly inside the turbine before being expelled through the radial tubes. While this reduces steam loss at the joints, it also creates new drawbacks. The water reservoir is much smaller, and the turbine becomes heavier, which reduces efficiency. To get the best of both worlds, the turbine can be connected to the reservoir using a special seal known as a fluid seal. A fluid seal separates high-pressure and low-pressure regions with a liquid. In this design, the turbine mates with the reservoir, leaving a small gap filled with liquid to prevent steam from escaping. Today, lubricating oil would be the ideal choice, but in the ancient world, they might have used something like olive oil, as long as the sealing liquid's boiling point is higher than water. Other than the seal, this version works the same way as the original Aeolipile. Water is boiled in the reservoir, converted to steam, and directed out through the radial tubes to produce rotation. It's important to note that Hero of Alexandria never built a fluid seal design. This is simply my own theoretical idea of how such an improvement might have been made. Now that we've explored the different designs of the Aeolipile and even imagined some possible improvements, let's consider whether it could have been used for practical work. Modern experiments show that the engine is capable of lifting a small weight, but its efficiency was only about 0.01%. To put that in perspective, if a large fire produced 10,000 watts of heat, the Aeolipile would deliver just 1 watt of useful work. By comparison, the new Cummins engine of the 1700s, the first commercially viable steam engine, reached an efficiency of about 0.5%, making it 50 times more effective than Hero's design. For the Romans or any other ancient civilization to truly harness steam power, they would have needed to invent something closer to the new Cummins engine. At the time, however, there was little incentive to pursue such a technology, since societies already had an abundance of cheap labor to perform manual work. Although there is one example of the Aeolipile, or an Aeolipile-like design, being put to practical use. In the 1500s, in the Ottoman Empire, it was adapted to rotate a spit of doner kebab, arguably the most fitting and most delicious application of this early steam engine.